Right, hello everyone. Today we're going to have a look at patterns. Okay, so first of all, we're going to look at two different kind of broad ideas of patterns. Okay, the first is ones that uses shapes. So, for example, triangle, square, cross, and um, let's pick another shape if I can. Uh, Hexagon. Worst hexagon ever. Okay, and then here we go, triangle, square, plus, and then so on and so forth. So this is a repeating pattern. So let's see how we would, describe this repeating pattern. So what you're looking for is you're looking to see when does this pattern begin again. So as you can see, it repeats every 4. So once you know that, then you can look at, well, the position of the different elements of the pattern. So this is in position 1. Now, position is also called term, the first term. So from now on, I won't use the word position, I'll use the word term because it's more mathematically correct. Okay, so this is the first term, the second term, the third, the fourth, and then it starts to repeat. So if it repeats every fourth, then if I want to know the 12th term, then all I have to do is divide 12 by 4, and if it goes evenly, then it must be the fourth term. And it does. It goes 3 times with no remainder, so the 12th term is in fact a hexagon. If I want to know the 123rd term, I could write them out the whole way and keep going until I have 123 shapes in front of me, or I could just divide 123 by 4, and 4 into 123 goes 30 times with a remainder of 3. So we do know there's 30 of these patterns and there's 3 extra ones, which means 1, 2, 3. So the 133rd term is indeed a plus. Okay, so that's how you do it if it's shapes. It's the easiest way to do it if it's a repeating pattern. Okay, so now let's have a look in more detail at how we deal with the number version of this. So let's pick a set of numbers. Let's pick 5, 7, 9, 11, 13, and so on. So in order to determine how to predict the future terms in this sequence, we first need to determine whether or not this is a linear pattern. So if I take away the 2 numbers, I have to add to get the next, and I have to add the same number. This is the same. So we call it, if it is the same, we call it linear. So it's a linear pattern. And we call the difference between them, that we call the +2, is actually called the common difference, because it's common between every, so I could pick 2 numbers side by side somewhere far out in this sequence, and the difference between them will be a +2. So that leads us then to how do we actually figure this out. So in your log tables you will find what's called the nth formula. And the nth formula is for any term in the sequence. It will find any term you want. So the formula looks like this. Tn is equal to a plus d times n minus 1. So I'm going to explain what all these letters are, and then I'm going to explain how I can use this to figure it out. So I'm going to move on to a new page to show you this. So I'm going to rewrite the pattern up here. 5, 7, 9, 11, 13. And we know already that there's a +2 between each number. And this is our formula, our nth formula. So, how do we use this formula to predict something very far up in the sequence? Well, the A is always the first term in the sequence. So in this case, A is 5. D is the common difference. And we've already discussed what the common difference is. It's the number that makes this a linear pattern. It's the difference between each that's the same. So in this case, D is 2. So I'm going to put these both into this formula. So our nth formula is 5 plus 2 times n minus 1. Now, you can leave it like that. However, you're expected to be able to tidy this up by multiplying out the bracket. So that's 5 plus 2 times n, and then 2 times minus 1 is minus 2. So that our nth formula is actually 2n. Always put the n first. 5 subtract 2 is 3. So this is the formula. This is the nth term formula for this sequence of numbers. Now let's see, is it the nth term formula? I'm going to find the first. So look, I've replaced the n with 1. That means in here I replace the n with 1. And it is indeed 5, the first one. Let's see, is the fifth one 13? And it is. And let's try and find the 200th one, because it'd take me a long time to add up to 200. 2 times 200 plus 3. The 200th term would be 403. So that's how you use this to figure out the nth formula. Now, we're going to have a look now at what happens if you actually want an answer. So, let's imagine we have this pattern. 5, 7, 9, 11, and 13. And let's say we know our A is 5. We know our D is 2. And we know our nth formula is 2n plus 3. So that's what we've worked out so far. Okay? What n? Which number would I have to put in there in order to give me 407? In other words, if I keep going here, eventually I get to 407. How many terms have I had to do to get up to 407? Now I could do it on the calculator and work it out, or I could figure out that, well, some number when I put it in here, into this formula, gave me 407. So just make my formula equal to 407 and then solve it for the missing one. So how am I going to solve it? Well, I'm going to take away 3 from both sides. And then I'm going to divide both sides by 2. So the 202nd term will give me 407 as an answer. So in other words, that's the first term, the second, the third, the fourth, the fifth. If I keep going up, this is the 202nd number on my list, and the number there is 407. So that's how you do that.